Okay. So this is the review for chapter 7, 8, and 10. On Wednesday, I will be also doing a video that has a review for the final. But let's go ahead and wrap this chapter up. So we know, well, first off, it doesn't really matter how you solve this as long as you solve it. Because I won't be able to tell which way you solved it. It says to solve it by factoring. One way that we solved this was using our graphing calculator. I'm going to go there and I'm going to do that real quick just to remind you. I'm also going to show you the other way, but if you use your graphing calculator, you would go to your apps. Let me get out of this. So I'm going to go to my apps. I'm going to go to this poly simulator which is number 9. And I'm just going to go in and hit Polyroot Finder, and this is a 2nd degree because the highest power that it is raised to is a 2nd. I want to hit graph to get to the next button, and then you just go in and type over. So ours was 2n squared. Instead of n, we're going to use x plus 3n. So we would say plus 3x, and then ours says minus 14. Okay, and then we can hit right up, it says solve right here, so we can hit graph, and it'll tell us our 2 answers are 2 and -7/2. And both of those would be perfectly acceptable for this. And that's how they've typed their answers in. So we could just come over here and say, well, the answers are -7/2 and 2. It doesn't matter what order you put them in. You could have reversed it and said 2 and -7/2. Another way to do this without the graphing calculator, and I'm just going to go into this because I know there's some people that may not have that app on their calculator, but you could do, if there's a number in the front, you would take the number in the front and multiply it by the number in the back. 2 times -14 is -28. And then our middle number here is 3. So we're really looking for 2 numbers that multiply to give you -28 and add to give you 3. Okay, so you have to kind of brainstorm that. We know that 28 times, let's see, 2 times 14 is definitely 28, but that's going to be too far away. So the next thing I can kind of think of is 7 and 4. So if we're going to do this, we would want a +7 and a -4, because 7 times -4 is -28, but 7 plus -4 is +3. When there's a number in the front, you have to divide by that number. Okay, and then it's always going to be you're going to reduce the fraction. This fraction won't reduce unless you make it an improper fraction, but it's always going to be the opposite of whatever you get here. So on this one, I would get -4 divided by 2 would be -2, and you would want to put the opposite of that, which is +2. So those 2 would be your answer. Okay, this problem. I'm looking at these and I'm noticing that they're both imaginary because you can't take the square root of a negative number. So I'm just going to have you recall that the square root of -1 is I. So if I rewrite these as -1 times 16 and then -1 times 9, well, you would see that I could split these up and be like the square root of -1 times the square root of 16 times the square root of -1 times the square root of 9. Well, this would give me an I. The square root of 16 is 4. This would give me an I, and the square root of 9 is 3. So we put all that together, we would have I times 4 times I times 3 Well, 4 times 3 is 12. I times I is I squared. So you're also going to need to remember that I squared is the same as -1. So this really means 12 times -1, which is -12. Okay, that's going to be the answer for that. Like this is saying to solve this. To solve this particular type of quadratic, we can just use algebra. So we could subtract 8 from both sides of our equal sign. We would get 4x squared is equal to -8. We would divide by 4. Okay, I'm going to write this over here. These 4's would cancel out. We would get x squared. -8 divided by 4 is -2. Then we would want to take the square root of both sides. Well, we know we can't take the square root of -2, but we can say that it is -1 times 2. And the square root of -1 is I. So we could write this as plus or minus. Remember, you always have a positive and a negative. I square root of 2. Okay, plus or minus I square root of 2. Use the quadratic formula to find the exact solutions. I'm going to go ahead and work it how the problem is asking me to work it. You need to know on this type of problem that you have to have it equal to 0. So when you're going through here and this is not equal to 0, you're going to need to move that 2 over and make it equal to 0. Okay. Now the quadratic formula is x is equal to -b plus or minus b squared. Sorry, got ahead of myself a little bit. The square root of b squared minus 4ac all over 2a. And remember that the a is the number in front of the x squared, b is the number in front of x, and c is your constant term. So if we're going to work this, now you could also probably get the answer in the graphing calculator by typing this formula into that app that I showed you, this one right here. Okay, I'm going to work it how it asked me to work it though, and I'm going to say, okay, b is 6. So this is going to be -6 plus or minus the square root of b squared, b is 6, minus 4 times a, in this case, which is 9, times c, in this case is 2, divided by 2 times a, which is 9. I would strongly say do not try to type all of that in the calculator at one time. I'm going to get this part, this 6 squared minus 6 squared minus 4 times 9 times 2. Okay, and that's giving me a -36 all over 18. Okay, now I want to see if I can reduce this any. I know that 6 times 6 is 36, and I know this is a negative underneath the square root, which means I'm going to have an I. So one thing I can do is say, well, this right here is 6i. I'm getting this 6 because 36, the square root of 36 is 6. I'm getting the I because there's a negative. Okay, and then I've got it under 18. The last thing that I'm noticing about, or one of the things I'm noticing about in this problem, that every one of these things, these numbers, can be divided by 6. So if I do the -6 divided by 6, I'd have -1. If I do 6 divided by 6, I would have +1i, and 18 divided by 6 would be 3. Now, we don't really need the 1 in front of the I, but these would be our two answers, -1 plus I divided by 3, and -1 minus I divided by 3. So this is what goes way up here. That one kind of took a while because of the way it wanted us to solve that. So express this in terms of I. Well, I know that I can separate it out and say that's -1 times 14. okay? But 14 is not a perfect square, so I have to look at the factors of 14, and I know that 2 goes into 14 7 times, and that's prime. So what I was trying to see was there any pairs that I could pull out here? And there's not. So the only thing I can pull out is an I, and of course, it's going to be 14 still underneath the square root. So we could either write it like that, or you could write the square root of 14 and put the I in the back. Just make sure the I is not under the square root sign. Okay, number 6 says, use the quadratic formula to find the exact solutions of the following equation. Well, we're looking at this and we see that it's not solved for 0. So we're going to need to subtract 36 from both sides of our equal sign, which would give us x squared minus 9x minus 36 is equal to 0. So now we're good. Remember that a comes in front of the x squared. If there's nothing there, it's just a 1. B is in front of the x. C is the other number here. So the formula, I'm just going to remind you, x is equal to negative b plus or minus b squared minus 4ac all over 2a. Well, in our case, b is negative 9, so that's a negative 9 plus or minus the square root of b squared, so negative 9 squared minus 4 times a, which is 1, times c, which is negative 36, all over 2 times a. Okay, please don't try to type all of this in. I don't know why it keeps going to a different screen for me. I apologize. I'm trying to scroll down and it's not wanting to cooperate. Oh, let me scroll down on this. Okay, sorry about that. So we would have positive 9, and then I would probably try to type this in my calculator instead of trying to accomplish all of that in one calculation. So we would have negative 9. We want to square that whole thing, minus 4 times 1 times negative 36. Okay, I'm getting 225 here, and that would be over 2. Now, one thing I know about this is the square root of 225 comes out even, I'm pretty sure. Yeah, the square root of 225 is just 15. So one of our answers is 9 plus 15 over 2. It comes out to be 12. The other answer is 9 minus 15 divided by 2. Which ends up being negative 3. So the two solutions in this problem answer is going to be 12 and negative 3. Now you can put those in the reverse order and that's fine. So it's just 12 and negative 3. Okay. Number 7 says determine the leading term, the leading coefficient, and the degree of the polynomial. Then classify the polynomial as constant, linear, quadratic, cubic, or quartic. Okay, so before I even get started here, what you want to do is you want to put this in order from least to greatest according to the variable's exponent. So the highest power exponent I see is an x to the 4th, so we really want that to come first. Then it would be plus 8x to the 3rd, and then it would be minus 6x squared, if we go in order from the biggest to the smallest. So the leading term is whatever is here in the front. It's going to be the whole term that's there. If there was a number there, it would go with it too. The leading coefficient of the polynomial is whatever number is in front of this leading term, and if there's nothing there, we know it's just a 1. The degree of the polynomial is the highest power exponent, which is going to be a 4. And since it's a 4, it is quartic. Okay, so a constant would be it had no variables at all. Quadratic would be the highest power would be a squared. Quartic is raised to the 4th. Cubic is raised to the 3rd. So this would be an x to the 0. This would be x squared. This is x to the 4th. This is x to the 3rd. And linear would just be an x to the 1st power. Okay. It's asking me to solve this. I could use my calculator to do that and type it in that polyroot finder. I could also just draw this x and say what multiplies to 2 and adds to, since there's nothing in front, I don't have to multiply that, adds to -1. Okay, so what multiplies to 2 and adds to -1? Well, it didn't work out as nice as we like. So we've got to go to our quadratic formula because there's not anything that multiplies to 2 and adds to -1 that we can are able to think of here. So we need to do our -b plus or minus the square root of b squared minus 4ac all over 2a. Now a here is going to be 1, b is going to be -1, and c is 2. So we would have a -1 because b is -1 plus or minus the square root -1 squared minus 4 times 1 times c, and c ends up being 2, all over 2 times 1. Okay, again, I would not try to plug all of this in the calculator at once, but I would try to do this part that's underneath, get it simplified, and then we can see if we can take the square root of it. So I'm typing in -1 squared minus 4 times 1 times 2. Okay, that's going to give me -7 over 2. Now, we know that this is imaginary, so we could rewrite that step as 1 plus or minus I square root of 7 over 2. And then that's the answer. There's two things there. And those are both, that would be what we would get. Okay. This one's a little bit easier. To multiply this, we would want to use the distributive property. So we would want to say 7i times 9. And then we would want to, since this is a minus, 7, or so that 2i can just be in the front. It doesn't matter, times 7i. Now this is going to get us 63i, 7 times 9, minus 2 times 7, which is 14, and I times I is I squared. Now remember that the square root of -1 is I, not negative I, sorry. The square root of -1 is I, and I squared is equal to -1. So on this problem, we can't really do anything with the 63i, but this -14 times I squared is -14 times -1, which is going to make the answer be 63i plus 14. You could also write that as, it's the same thing as 14 plus 63i, same answer. Okay. Classify the polynomial as constant, linear, quadratic, cubic, quartic, and determine the leading term, the leading coefficient, and the degree of the polynomial. Okay, so this one's already in order. The x to the 3rd is in the front. If it's to the 3rd, we know that it is cubic. The leading coefficient is going to be -2x to the 3rd. The leading term is -2x to the 3rd. That would be everything in the front. The coefficient is a -2. It's the number in front, the constant term in the leading coefficient and the leading term, sorry, and the degree of the polynomial is the highest power that it's raised to, which would be the third degree. Okay, they're asking us to solve this. When it's already factored like that, the easiest thing to do is break it into two parts and solve it from there. So you're seeing, well, when is 9a plus 7 equal to 0? And when is 2a minus 6 equal to 0? So we would subtract 7. So 9a is equal to negative 7. Then we would divide by 9 and get a is equal to negative 7/9. So there's one answer. This one we would add 6. So we would get 2a and we would divide by 2. So a is equal to 3. Okay. It's asking us to add these. Now you can use your calculator to do this if you want to, but remember that you're adding the same things in the same places. So if we're adding a and b, we would do 4 plus negative 5 in that first spot. In the second spot, we would do 3 and 9. In the third spot, down here at the bottom, we would do 1 plus 2. And then last, we would have 6 and a negative 6. Okay, and that's going to give us our answer. 4 plus negative 5 is negative 1. 3 and 9 is 12. 1 and 2 is 3. And then 0 right here. And that is the answer to that one. I feel like we've already had a problem similar to this, but that's okay. We can break this up into negative 1 times 16. Well, the square root of negative 1 is I, and the square root of 16 is 4. Most of the time, you're going to see it written with the I in the back. Okay, and that is the answer to that one. Number 14 says to use the graph of f of x to find the x-intercepts of the graph and the zeros of the function. Okay, now this is important. When the x-intercepts, you want to make sure you put the whole coordinate. Here's 1. So that point is the point negative 2, 0, because we go over to negative 2 and we don't go up or down any. So it's going to be negative 2, 0. Then it's asking you to separate by a comma. This one, we go over 5 and we don't go up or down, so it's just 5, 0. So those are your x-intercepts. They should be listed type ordered pairs. That's going to be important. Don't just put 2 and negative 2 and 5, because you're supposed to do that when it asks for the zeros of the function. Okay. And then these don't matter. I mean, you could switch these. You could switch these. They don't have to be one in front of the other. Doesn't matter which one comes first. Okay. So determine the order of the matrix. I always say go down first and count and then go over. Well, if we go down first, on this one, we have 1, 2, 3, 4. So it's a 4. Then go over 1, 2, 3, 4, 5. So it's a 4 by 5. Go down first, then over. Okay. Number 16 says to subtract these. So we're really doing the opposite of whatever is behind here. So since there's not anything in front of the first parentheses, we can just write 13 plus 5i minus 4. And then we want to distribute the negative to the other answer, so negative 2i. Well, we want to combine like terms. So the 13 and the negative 4 can come together. 13 minus 4 is going to be 9. Also, the positive 5i and the negative 2i can go together. 5i minus 2i would be positive 3i. That's going to be the answer to that one. Okay. Certainly welcome to type this in the matrices. If you didn't catch that, you can go back and look at the lesson, but you could do this one in the calculator, 17 if you want to. I just think it's almost as much trouble just to work the problem out. So they're saying they want you to multiply everything in A by 2. Okay, so we're going to do everything here by 2. So it's going to turn into a 6, an 8, a 16, and a 2. So that represents 2A. Then we're supposed to subtract 4B. So I'm going to take everything in this matrix right here and multiply it by 4. So negative 4, 8 times 4 is 32. 5 times 4 is 20. Negative 3 times 4 is negative 12. So this is going to be 6 minus negative 4. Well, that's 10. 8 minus 32. Okay, that's going to be negative 24. 16 minus 20, negative 4. 2 minus negative 12 would be 14. Okay, and that is going to be our final answer on that. So, what did I do wrong? 8 minus 32. Oh, I'm so sorry. It says plus. So, if I was going to subtract them, this would be the answer, but we're not subtracting, we're adding. I misread my sign there. Sorry about that. So, 6 plus negative 4 is going to be 2. 8 and 32 is going to be 40. And 16 and 20 is 36. 2 and negative 12 is going to be negative 10. Okay, so this is going to be your answer. If we were to subtract them, we would have got what I got there, but I didn't read that. Sorry about that. Okay, number 18, it says determine the leading term, leading coefficient, all this good stuff about this quadratic. It is written in order for us. We've got our x squared first, then our x to the first, and then our constant term. So our leading term would include this whole thing, 1/3 x squared, negative 1/3 x squared, sorry. Our leading coefficient would be negative 1/3 then, because it's the number in the front. The degree of this would be a second degree, and the second degree is quadratic. Okay, asking us to solve this. We don't usually solve things that have a to the third power, but what I'm noticing is there is a y in each one of those. So I could pull a y out, so that would give me 5y squared minus 19y minus 4. Okay, so one of my answers here, because we've got one of my answers just goes straight to y equals 0. So I could put 0 down. Okay, this part right here, I'm going to go ahead and type that in the graphing calculator real quick. You could work it by hand. You could use a quadratic formula. It doesn't matter. I'm just going to go ahead and we've worked it several different ways. Let's go to our calculator. And I could even, if we go back, so I'm going to apps. Let me get out of this. Okay, next. And we want to type over. So what we had left after we pulled that y out of this problem was 5 x squared. It was really a y, but that doesn't matter. Minus 19 and then we had a minus 4 on the end. So negative 1/5 and 4 are going to be our answers there. Okay, so negative 1/5 and 4. wants us to solve this one. So we would want to get this equal to 0. So we've got 16z squared. I'm going to move that 96z over by subtracting it. Okay. Now, what you want to try to do is think if any of these things have anything in common. I think I'm going to go show you on the graphing calculator what the answer would look like if we did it this way. So let's look at that real quick. I think a lot of you are going to decide that that probably is going to be the way you want to work it. You could use the quadratic formula. We've already worked several like that. So okay. So this time we do have okay, in our formula, this was, sorry, having trouble going back and forth. This was 20. So the problem was 16 z squared, which we're still going to use x, and then it was minus 96 x, and then it was plus 137. Okay, now hit solve. Okay, now you'll notice that these right here are kind of not what we had in mind, right? They don't look, we don't want decimals like this. So if you see this fraction to decimal, if we hit that again, hold on just a minute. And it might not function on this calculator. So we really want it to list it out. It's a real number, so we don't have to worry about that. That's okay. For some reason my app is not wanting to let me do it, but usually it does have a place where you can convert them back. So on this one, we're actually going to have to work it the longer way. But on your calculator that you're probably seeing right now, you're probably able to push that. I don't know why it's not letting me, but I will just get out of this and we'll solve it. So the problem that we have, so I'm talking about this formula right here. X is equal to negative b plus or minus the square root of b squared, which is one of the reasons why, you know, your calculator on any given day, that's just the one on my computer. The one on the actual calculator I have will do it the way we were going to do it, but you never know when that's not going to function, which is a good reason for you to actually know the formula. So our A is going to be 16, B is negative 96, C is 137. So this would be negative 96 plus or minus negative 96 squared minus 4 times 16 times 137. That looks like that's going to be a really big number, all over 2 times 16. Well, I know 2 times 16 is 32. Okay, I know a negative 96 is just 96. So let's figure out what's underneath these parentheses. So negative 96 squared minus 4 times 16 times 137. That's 448. Okay, now I can imagine that 448 has some things that we're going to be able to pull out of it. So if we look at 448, we know 2 will go into 448. And that will go, what, 224? Two will go again, 112. 2 is going to go into 112. See, I'm looking for pairs that I can pull out. I'm just needing to reduce this fraction. So that's going to give me 56. 2 will go into 56. 28 times. 2 will go into 28. 14 times. 2 will go into 14, 7 times. So what we have here is 96 plus or minus. Now, if all of this is 448, I can pull out a pair of 2s, another pair of 2s, another pair of 2s, this one right here. And that would be 2 times 2 times 2, which is 8. And we would have a 7 left under here. And all of that would be divided by 32. Now, 96 divided by 32 actually comes out even. If we kind of separate these out and do 96 over 32 plus or minus 8 over 32, we still have the square root of 7, we can reduce these fractions. That's going to get us 3 plus or minus, well, 8 over 32 reduces to 1/4. So this would end up being the square root of 7 over 4. Okay, and those are your two answers, 3 plus the square root of 7 over 4 and 3 minus the square root of 7 over 4. Okay, great. So it says use these graphs to answer the questions. These are pretty easy. Just remember that you're looking for the x-intercepts, which would be right here. So it looks like we have an x-intercept at -2, 0 and at 3, 0. So the zeros are those two numbers, -2 and 3. Okay. It's wanting us to find x and y. We know that y is equal to whatever is listed in the same place. So y is -4. That one's not bad. The other one's not bad either. X is up here. So in the same position of this matrix, -2x is equal to 4. We would divide by -2. So x is equal to -2. It's like we're saving the easiest ones for last. Okay. To work this problem, we want to do the order of operations. And it's going to be important that you remember that I squared is equal to -1. But the first two terms, 3 times 3. So the first, the outer, is going to be plus 3 times -4. Inner would be plus 4i times 3. And then the last would be plus 4i times -4i. That's going to get me 9. This is -12. This is positive 12i. And this is -16i squared. Okay. Well, the only thing, so really, this right here means -16. I squared is -1. So this really ends up being a positive 16. So we could actually combine all of our numbers that are like terms. Here we have a 9 minus 12. 9 take away 9 minus 12 is -3. Plus 16 is going to be 13. Okay, and hold on a minute. What have we? but I left off an I up here. So 3 plus 4I times 3 minus 4I. Let me go check because I think I've done something wrong or missed something. 3 times 3, 3 times negative 4. I did. This is supposed to have an I right here. So that means this would have an I. So let's go back up, back up, back up, back up, back up. Not way off, but I didn't write down my I, which that's why I'm going too fast. I need to slow down. Sorry about that. Okay, so these two can go together. They're going to cancel out. And this is 9 minus 16. And since this is an I squared, that means times negative 1. So this is really 9 plus 16, which is going to end up getting us 25. So that's going to be the final answer. So all of that collapsed out to just being 25. Okay, we know that this is negative 1 times 98. So we already know we have an I. Now we can write our 98 and look and see if we have any pairs. 2 will go into 98 49 times. 7 will go into 49 7 times, and that's prime. So we do have a pair of 7s we could pull out, and we would have a 2 left underneath. Most of the time people would put the I after the number, but before the square root. The way that they like doing it in this computer is they like writing it like that. I don't like that because I think people try to put the I underneath the square root, and it's not supposed to be there. So either the computer should take this one or this one. Okay, last problem. If it's a plus, nothing changes. So you could just drop your parentheses, combine like terms, the 3 and the 9, it's going to be 12. The negative 3i and the negative 8i is negative 11i, and that's going to be the final answer. So that is the review for chapter 7, 8, 9 test. I'll be working on the final review Wednesday, and I will also post that